Have you ever wondered how you teach an AI to play a game? I mean, not just play it, but to really master it? Well, today we're diving into a brand new project that is completely rewriting the rules for how we train AI. Right, so how do you do it? It's not like you can just hand an AI a rule book and say, here, read this. Nope, it has to learn the same way you or I would, by just doing it, by playing and failing and figuring things out. And that idea right there is a core concept in the world of AI. It's called reinforcement learning, and you can just think of it as this massive, super fast game of trial and error. You've got an AI agent, it plays a game, it makes a move, it gets a score, and then it does that again and again. We're talking millions, even billions of times. And that's pretty much the secret sauce behind how AI learns to master everything from, chess and Go to something as complex as self-driving cars. But, and this is a huge but, there's a catch. This whole process, it is painfully incredibly slow. I mean, a single training run can take days, sometimes even weeks, and it needs to run on these super powerful, super expensive computers. So what does that mean? It means there's this massive barrier to entry. It basically makes cutting-edge AI research a game that only the biggest companies with the deepest pockets can really afford to play. Okay, so what if we could just change all that? What if you could take those weeks of training and crush them down into just a few minutes? Well, that is exactly what a new library called PufferLib is doing. And believe me, this isn't just a small step up, it is a total game changer for the entire field. I mean, just look at the difference here. It's just astounding. Your typical traditional systems, they can process a few thousand of these practice runs, or steps as they're called, every second. PufferLib, it can process over 4 million per second. So let's put that in perspective. A project that would have taken you a whole week before, yeah, now you can get it done in the time it takes you to go make a cup of coffee. It's that dramatic. Seriously, let that number sink in for a second. Over 4 million practice sessions every single second. And this is all running on just one GPU. This isn't some small improvement, you guys. This is a monumental leap forward for efficiency and pure speed. And this speed has some wild real-world results. Get this. The team behind PufferLib taught an AI to play the classic Atari game Breakout, completely from scratch. The AI knew absolutely nothing about the rules. And in just 30 seconds, it had learned enough to play the game well. I'm not kidding. 30 seconds. Okay, so how? How is that even possible? What's the secret sauce here? What's the magic trick? Well, it all comes down to a few really clever engineering solutions that just smash through the biggest bottlenecks in reinforcement learning. So let's pull back the curtain and see how they did it. It basically boils down to 3 key ideas. First, a really smart way to run lots of simulations at once. Second, a system that kind of acts like a universal translator for all the game data. And third, a foundation of super fast environments. Let's start with that first one, which is all about something called vectorization. So, to get what they did here, think about it like this. Imagine you've got a classroom of students all taking a test. Now, in the old way of doing things, you couldn't grade any of the tests until everyone was finished. So you've got your fast students who are done in 10 minutes, just sitting there, twiddling their thumbs, waiting for the slowest student to finish up. It's super inefficient, right? All that wasted time. Well, PufferLib's solution to this is just brilliant. Instead of waiting for everyone, it basically just invites way more students to the test than it needs. So say it needs 24 finished tests. It'll just run, 64 simulations. And the second the first 24 are done, bam, it grabs their results and moves on, completely ignoring the slower ones. No more waiting around. No wasted time. Genius. Okay, so the second big idea tackles how complicated game data can be. Modern games have all this complex data, what the pros call hierarchical observation spaces. Just think of it like folders inside of more folders of information. The problem is, most AI algorithms, they're simple. They just want a flat list of data. So what PufferLib does is act like a universal translator. It takes all that complex nested data, automatically flattens it out into a simple list the AI can work with, and then when it needs to, it just puts it all back together again. Seamless. And that brings us to the third breakthrough, which is all about pure, raw speed. See, most AI research happens in Python. Why? Because it's pretty easy to write and work with. The downside? It's kind of slow. Then you have a language like C, which is just lightning fast, but it's way harder to use. So for ages, there's been this trade-off. Do you want something that's easy to use, or do you want something that's fast? You couldn't really have both. Until now. PufferLib basically gives researchers the best of both worlds. It comes with a bunch of tools and templates that make building these super high-performance game environments in C almost as easy as it is to do it in Python. So you get all the blazing speed of C without all the usual headaches. It's a huge win. So look, this isn't just about making an AI that can beat video games faster. This kind of insane efficiency, it has much bigger implications. This is about leveling the entire playing field. It's about changing who can actually do this kind of cutting-edge AI research. And this chart, this tells the whole story. On one hand, you've got the big tech labs. They're using these massive computing clusters that cost hundreds of thousands, if not millions of dollars. And on the other hand, you've got the PufferLib team. They achieved their record-breaking results using just 8 consumer desktop PCs, costing about 35 grand. It is a total David versus Goliath story, where smart engineering just completely beats raw, expensive power. And you know what the best part is? They're not keeping this to themselves. They're giving it all away for free. PufferLib is completely open source. The code is right there on GitHub for anyone to use with a super permissive license. This is a tool that was built by the community, for the community. The whole point is to empower researchers no matter where they are. When you get right down to it, PufferLib is this powerful reminder that progress in tech isn't always about who has the biggest computer. It's about clever engineering, it's about smart design. It proves that a small team with a really great idea can still achieve things that just a little while ago seemed completely impossible. And that leaves us with a really exciting question to think about, doesn't it? If we can solve a problem this huge, the speed of AI training, what's the next impossible problem that's suddenly within our grasp?